Hi folks, another chapter 4 problem, and here we go. A 150 Newton bird feeder is supported by 3 cables. Find the tension in each cable. So again, we have a static situation, so the sum of the forces in the x direction equals 0, and the sum of the forces in the y direction equal 0. And we are looking for T1, T2, and T3. Now T3 is the entire weight of the bird feeder is suspended by cable 3. So that is like a dead fish sort of situation. So T3 is going to be that 150 newtons. That's going to be the entire weight of that bird feeder. So we know T3, but T1 and T2, we're going to break those into components so that we can get the left and right forces and the up and the down forces. So let's go ahead and do that. And I'm going to draw them a little large because I want to make sure that I can show you those vectors. So here's going to be my triangle to the right. That T2, and like I said, I'm drawing these big so you can see what I'm doing. T2 is pulling up and to the right, alternate interior angles. If that's 30 degrees, this is going to be a 30-degree angle. I'm going to have a force up, and I'm going to have a force to the right. T1, excuse me, is going to be up and to the left. And again, alternate interior angles. If that was 60 degrees, that means this is going to be 60 degrees. We are going to have a force up, and we're going to have a force to the left. So when we draw our equations, the sum of the forces horizontally or in the x direction are going to be equal 0, and the sum of the forces vertically or in the y direction are going to equal 0. Why do we know that? That's a Newton's first law situation. Static, all the forces add up to 0. When we draw our equations, the forces right and left are going to equal 0, and the forces up are going to equal our force down. And what's our force down? Our force down, of course, is going to be the force of gravity or the weight of our little birdhouse. So let's go ahead and draw our equations. Force X, so this is going to be the horizontal stuff. This is going to be the left and the right. So the force left is going to equal the force right. That's going to be this component of this triangle. If this is T1, this is the adjacent side. So this is going to be T1 times the cosine of 60 degrees is going to equal this component of this triangle, which is going to be T2 times the cosine of 30 degrees. So my left forces are going to equal my right forces. My up and down forces, my 2 forces up, are going to equal my 1 force down. So this force up is going to be T, and I'm going to change colors so we can keep our equations straight. This is going to be T1, this is my opposite side, so times the sine of 60 degrees, plus this up force, T2, times the sine of 30 degrees, is going to equal my 1 down force, which is the force of gravity, which we were told is 150 newtons. Now, we have 2 equations. We have 2 unknowns. We do not know T1 or T2. So what we're going to have to do to solve this is we're going to solve for one and shove it into the other. And for no good reason, I'm going to solve for T1. You could just as easily have solved for T2. I don't know. T1 just looks spiffy to me. So T1 is going to be T2 times the cosine of 30 divided by the cosine of 60. And if you recall, if you are going to carry through, the best way, of course, is to carry these through as cosines and not convert them to decimals. But if you are uncomfortable doing that and you want to convert them to decimals, carry them out at least 4 digits. So if I go cosine of 30 divided by the cosine of 60, this ends up being 1.732 on my wee little calculator. And now that I have this as a value for T1, I am going to put this in place of T1 in that equation. So let's write that out. So I'm going to have T2, because my goal is to eliminate one of these variables, T2 times 1.732 times the sine of 60 plus T2 times the sine of 30. Now I've done this a long time, so I know the sine of 30 degrees is 1/2, equals 150 newtons. Let's simplify all of this. So the sine of 60 times 1.732, this is going to be T2 times 1.5 plus T2 times 0.5. When I add these together, 1/2 and 1.5 is 2, so I end up with 2 times T2 equals 150 newtons. So what does T2 end up being? T2 ends up being 150 newtons divided by 2, or T2 ends up being 75 newtons. That's what I get for T2. Now, what do I get for T1? Now that I have that, I'm going to shove that back up here, and I end up with T1 equals 75 newtons times 1.732. And if I do that, 75 times 1.732, I end up with T1 is 130 newtons. So there's T1, there's T2, and we found T3 was 150 newtons way up top, and that finishes that one. We'll see you later. Bye-bye.